Assalamu alaikum and a very good evening to all of you. I thank you all for joining today's webinar. This is the sixth episode of webinar organized by ReForm that aims to disseminate knowledge on crucial topics by distinguished faculties and practitioners from respective fields across the globe. We at ReForm aim to give Bangladesh a new scholarly face that the world values. Our mission is to bring researchers together through knowledge sharing and to innovate, enhance the productivity and technological advancement of Bangladesh. The title for today's presentation is Mineral Import Demand for Clean Energy Transition, a Disaggregated Analysis. And our today's speaker is Monirul Islam. A little bit about him. He is a PhD fellow at the Graduate School of Economics and Management in Ural Federal University, Yekaterinburg, Russia. In this PhD, he is working on the global clean energy transition issue and the consequence on natural environment. He has completed his Masters of Philosophy from the University of Dhaka, Bangladesh. His area of research mainly focuses on political economics, energy, and environmental issues. Mr. Monirul Islam has published 25 research articles in different peer-reviewed journals by this time. In addition to his credit, he presented 15 conference papers at various international conferences. To present an organized webinar, I'd like to request all participants to mute their microphones. A question and answer session will be held after the talk, and I'd like to request Mr. Monirul Islam to present his speech. The floor is all yours, bhai.
Okay, can I share my screen, please?
Sure, you can share your screen.
Can you see my sharing screen?
Yes, the screen is visible.
Okay, thank you very much. Dear moderator, Honorable Director, Bangladesh Institute of Governance and Management, my mentor especially, and he's my inspiration. And he asked me to do even my PhD studies here. And distinguished fellow colleagues, ladies and gentlemen, good evening. So today I'd like to present a topic. This topic is namely mineral imports demands and clean energy transition, a disaggregated analysis. Mainly this is my PhD paper. This is the first paper of my PhD. Dear fellow colleagues, you know that I'm mainly from the political science. My background is mainly political science, but after joining BIGM, I started work on mainly economics, covering the energy sectors, or like energy transitions and other relevant issues related to energy. And I prepared my proposal for my PhD in Ural Federal University under the laboratory that is called the International and Regional Economics. In short, it is called the LIAR. So when I came here, then my supervisor requested me, you have given the proposal, okay, it's fine, but we are under a particular laboratory and your fund is mainly, we are providing you under this lab. Then he requested me and he told me, we'll be happy if you study mainly on the topic, mainly the mineral imports and energy transition, because this is the talk of the town and it is the hot topic. So if you can work on this, then we'll be happy, because there is the issue of funding, there is many other issues, and Russia was at that time was in somewhat problems concerning the geostrategic or geopolitical issues. So my supervisor and co-supervisor, told me to study on the mineral, uh, critical minerals and global energy transitions. So I told them, okay, I'll try my level best. Then this is my starting, but it was not my plan to do on this, my PhD on this particular topic. But still, I'm trying to learn many things. So for your kind information, I am not expert at all in this field, and I'll not discuss here about how the technical issues of the minerals that are used in the clean energy plants or project, but I'll only highlight here the economic side of the mineral import laden clean energy transition in the global perspective. Mainly I will cover here the OECD countries, Organization of Economic and Economic Development and Cooperation, and this block, because this block is the very crucial blocks worldwide, and it consists of the 29 countries. So I would like to start my presentation. So this is the short background. So uh, Mahdi, mainly the moderator, considered me as the expert in this field, but I'm not expert at all. But I'm trying to learn something, and I'm trying to disseminate my gathering knowledge by publishing in the different journals. And I also presented some papers in different international, conferences and seminars. So I thought that I need to clarify this issue. So my topic is today, that is the minerals imports demand and clean energy transition, a disaggregated analysis. Before going to main discussion, firstly, I'd like to give the outline of my presentation. First of all, there will be the background and motivation. So how this study and why this study is important and necessary. What are the motivation that will help carry out this study. So firstly, there is a background and motivation, and then research objective and contributions. I have a particular objective here, and I'd like to explain my objective, overall research goals, and how this research contributes to the existing literature, mainly related to energy transition or mineral economics. Then model, materials, and method I'll also discuss about, and empirical findings, conclusion and policy implication, that is the fundamental parts of a particular research work. And finally, questioning and answering session. So you the guys, you will ask me the question, you will recommend, you will suggest how to develop my study, because by this time I have produced 10 papers on my PhD thesis. Four papers are published, and another six papers, or more than say, and in another field I have many other papers. All are under review, and most of and almost 90% of them are under review in the Q1 and high impact factor journals. So that is the great pleasure for me. So this presentation, that this topic that I would like to present, it is also published in the one of the A-star journal, ABDCT A-star Energy Economics. You know it very well. So, dear colleagues, dear audience, before going to analyze the background and motivation of my study, I would like to talk about what is, minerals or critical minerals, and what are the energy transitions. First of all, you all know that minerals are some types of metals. In all cases, it is not metal. So from that point of view, minerals are mostly classified based on the crystal form of classification of the minerals, and which has mainly two types. These are the metallic minerals, and another was non-metallic minerals. We may highlight in this study the metallic minerals, because metallic minerals uses that is mainly suitable for expediting the clean energy transition process, because there are many other clean energy technologies And for the manufacturing and operating the clean energy technologies, these minerals are used. Metallic minerals, consist of
Monirul
different
bhai,
types of.
I think it would be really helpful if the display was put in presentation mode.
Yeah. Can you repeat, please?
Can you kindly put the display in presentation mode?
Okay, it is not working, I think. Oh, no, now it's fine. Now it's okay. Thank you. Thank you very much.
Thank you. Thank you very
Now,
much.
please also Limon, please put your please mute your, yeah, okay, thank you. Okay, go ahead.
Sorry, sir. Sorry, it was not in the presentation mode. It was not working, I think. I clicked it. Okay, sorry
Okay,
for
no
this.
problem, no problem.
So metallic minerals, mainly minerals are two types that I was telling about this. So metallic minerals and non-metallic minerals. In this study, we mainly cover the metallic minerals and its use in the clean energy production process. So it has metallic minerals are two types, ferrous and non-ferrous. So non-ferrous metals are mainly based on the iron. So ironic characteristics of the metallic minerals is called the metallic minerals. So we mainly discuss here in this study, and it is effective for dealing or for manufacturing the clean energy technologies like solar photovoltaic, wind turbines, wind generators, electric vehicles, power storage system, etc. And if you'd like to say about the energy transitions, this is the one of the core idea, and that is grabbed by the many other countries policymakers just to expedite the process of energy transitions in their countries for reaching the decarbonized world and net zero emission trajectory by producing the renewable or clean energy transitions. So here transition means there is the global shift from fossil fuel based non-renewable energy production or consumption process to the renewable or cleaner production process. And non-renewable energy or fossil fuel, that is natural gas, oil, etc. And the world leaders want to shift from this non-renewable based energy consumption or production to the renewable energy transition trajectory like solar photovoltaic, wind turbines, electric vehicles, and power storage batteries systems. So this is the core two items, critical minerals. Here we will use the metallic minerals, and clean energy transition. Energy transition means the how the solar, wind power, and other types of technologies used in producing the cleaner energy or cleaner energy production. So dear audience, that minerals use are diverse. It is used in all aspects of the human life. It's mainly used for generating electricity, fueling vehicles, heating homes and workplaces, even for manufacturing plastics. Minerals, critical minerals are used. Even in the current age, there is the huge spread of mobile phone uses. So in the mobile phone, the microchips that is used for protecting the different instrument in the mobile phone. So the microchip, making the microchips, I think minerals like copper and other types of minerals, rare earth elements maybe, that are used. So minerals use has been diversified. Even in every aspects of life, minerals are used. And for this reason, we see the huge demand and supply portfolio of the mineral resources in the international market. It is because the abysmal consumption and production flows worldwide. But in the last decade, mineral uses has been dramatically increased due to global agenda of energy transition or clean energy transitions. Here, minerals are mainly used for handling the renewable technologies like solar photovoltaic, wind turbines, electric vehicles, power storage system. Here, minerals are used as the critical raw materials. For your kind information, uh, uh, the renewable technologies are more raw material intensive than the traditional, energy system. For example, I have given here the 1 megawatt solar power plant requires 3 times more copper than the conventional power plant. And nickel is also used in the different solar and wind turbines plants. Besides the indium, beryllium, cadmium, and silvers are also used for constructing the solar panels. And it very well electric vehicle system and power storage batteries, and that are widespread all over the countries. If you see the, Germany is going tremendously being going to hold the approach of electric vehicles, and they have the plan to they're all the vehicles in under the electricity control mechanism, where uh, uh, like the material like cobalt, nickel, that will be hugely used in their electric vehicle paradigm. Another I can also show that a general wind turbines or wind power, that is the another criteria of the renewable energy technology. So a typical wind farm uses 4 million to 15 million pounds of coppers for wiring and tubing the cables in wind generators. So wind generator in preserving power, or to rotor and rotor that are used in the wind generator or wind turbine system, it mainly use the copper. Even nickel is also used there, just preserving power, or to move or to moving from one cycle to another cycle of the wind power system. I think copper and nickel are tremendously used. And not only for this, nickel oxide as the whole transporting metal for perovskite solar cells that is used. And stainless steel, this is one type of that is used in the wind turbines, and that is made of nickel. So this is our mainly background. Another important motivation of our study is that the current world's move towards the decarbonized world or net zero emission trajectory. That is our one of the motivation to carry out this study. Their audience, uh, in the last in 2016, the Paris climate conference, where the global leaders emphasized to decarbonize, and there are different countries, and different countries promised they will reduce tremendously the carbon emission and something like this. And as very previously held climatic conference that is called COP26, where the international leaders expected that all the countries of the world, mainly emitter countries, they should they should have their attempt to reach to the net zero emission trajectory. Mainly, it would be reduced by 1.5 degrees Celsius temperature by reducing their emission, and it would be by the middle of the 21st century. So if the world's ultimate target of decarbonized world, or if they want to reach the net zero emission trajectory, and they must have to use the mineral resources for for expediting the clean energy transition process. Because in the clean energy transition or production process, minerals are used as the critical raw materials. So this is the one of the significant motivation of our study, that world's ultimate target to having a decarbonized world on net zero emission level. And in that case, renewable energy production is significant. And if the countries of the world want to go to the net zero emission level, they must produce huge renewable energy. So in that case, mineral would be the ultimate raw materials for expediting the clean energy transition process. Another important background motivation of our study, that is the OECD countries. Why you have selected OECD countries? OECD countries, mineral importing scenario is remarkable. If you see these countries' mineral rates, that were at around 30% as of 2017, and although in 2011 it was their mineral rent values was 45% as percentage of their GDP, and that was the highest in the last 47 years. But in 1919, this economy witnessed the lowest mineral rent value, and that was at 0.38%. From 1919 to 2017, there is the huge mineral rents these countries paid, and in that case, the country mainly imported different types of critical minerals from the different exporter countries. If we see in one of the statistics revealed that in 2020, the top countries which imported minerals include Australia, Brazil, Chile, Peru, and South Africa. Some of the countries, most of the countries are here from the OECD. And top partner countries and regions from the Europe and Central Asia, they mainly import the critical minerals. These are Brazil, Germany, South Africa, Canada, and United States. So here is the some of the most of the countries like Germany, Canada, United States. They're from the OECD blocks. And if you see the OECD countries mineral imports from 19 to 2020, so this data we mainly utilized in our studies. Here we see that Australia is the highest importer amongst all other countries in the OECD. And Chile, Canada, United Kingdom, United States, Turkey, Mexico, Germany, Japan, Korea. These are the major importers of the minerals, and so this is this escalating flow of mineral imports. I think that is another significant motivation of taking OECD countries in our studies model to carry out mainly the study covering the context of the OECD, mainly covering the import demands of the OECD, mineral import demands for the OECD countries. So based on our background and motivation, we select our research objective. So our objective is very straightforward and usual. In this study, we check whether the aggregate or disaggregate mineral imports demand respond to the global energy transition. And global energy transition, so we have divided into 3 clusters. First one, solar capacity, installed solar capacity, installed wind capacity, and renewable electricity generation in the case of 29 OECD countries, and we covered the period 1992 2020. So why we are telling about this is the disaggregated, decomposed or disaggregated analysis. Why? Firstly, we check the response of total mineral import, aggregate mineral imports demands response to the 3 clean energy transitions parameters. This is the solar capacity installation, wind capacity installation, and renewable electricity production. And then we consider, we take the disaggregate or cluster form of the critical minerals. And this is the copper and nickel, because I previously discussed that copper and nickel, these are the two significant minerals that are used for energy transition. Like it is, these are used for solar, wind and renewable electricity generation process. So we disaggregately, see the response of the critical mineral imports demands to the OECD countries energy transition. That's including install solar capacity, install wind capacity, and renewable electricity generation. So this is our objective, and our contribution we is here. Mainly we use the input demand function just to see the response of the mineral markets in the context of OECD countries. This is previously no studies, I think, to the best of our knowledge. So we see that no study, conducted in this way just to cover the OECD countries and to see the disaggregated or decomposed measure of the response of the critical minerals to the decomposed measures of the energy transition, including solar capacity, wind capacity, and renewable electricity generation. So this is our value addition to the energy or mineral economics literature. So here, some of the economics related some technical issue, but it is not so critical. It is very easy. So from that point of view, and most of the people are present here, all are the researchers. So I can, explain a little bit. So import demand function of the critical minerals. Usually we know that an individual consumers demand for a particular good. Here J is the demand and I is the particular commodity, and that mainly depends on the income and other this particular goods price and some complementary or substitute goods price. So that is, in that case, the utility function we can write here. So quantity demand is the function of income and price of the particular goods, and price of the other goods like complementary goods and substitution good. So if we transform the consumer aggregate demands into the a demand function of an and that mainly depends on the economics aggregate income like Y and the commodity price. So from that point of view, quantity demand is the function of this particular country's income, price of that particular commodity, and price of the other commodities relating to this. A particular country mainly supplies Y when this country doesn't satisfy its particular demand. So in that case, import demand function depends on the respective country's income, price of the goods of international markets. So here the price and the relative price of the individual goods at home and abroad, and that is mainly explained through the real exchange rate. So from that point of view, we quantity demand of minerals or of the nations. Here it is the function of income, price of the particular price of the other goods or the complementary substitution goods, and the exchange rate. So in this study, we consider renewable energy production or transition. It consists of the three important determinants like solar, wind, and renewable electricity generation. We considered here as the technological innovation in this study. And from the we just follow the two significant studies, and that was also published in Energy Economics. So we now our theoretical equilibrium model is like that. Mineral imports demand is the function of, like, this is the technological parameter, and this is the income, this is the price of the particular good, this is the substitution goods price, this is the exchange rate, and we also considered here the clean energy transition, and these three elements as the technology innovation in our model. And this is the white noise error or error terms in our study. So this is our empirical model, and we execute this model using the CSERDL or cross-sectional auto-regressive distributed lag model. So this is the data description. What are the data we are used for our study? First of all, the aggregate features of the mineral imports. Here, total mineral imports volume in metric ton, measured in 1,000 we considered. And here we can see the disaggregate mineral imports like copper imports, total volume of copper imports in metric ton, 1,000 measured in thousands, and nickel imports. This is the disaggregated mineral imports demand of the OECD countries and total size of the nickel imports in metric ton that we are used. And our sources of data are mainly the British Geological Survey and World Integrated Trade Statistics data we mainly used for mineral imports, aggregate mineral imports, copper imports, and nickel imports. And our independent variables are here, the three clean energy transitions parameters. These are installed solar capacity, installed wind capacity, renewable based electricity generation. I think it can also call that renewable electricity generation. So here for the solar capacity or solar capacity in installation, we have considered the cumulative installed solar energy capacity in gigawatts. So in terms of wind capacity, we also use this, but here we not only consider the onshore production capacity of wind, but the offshore production capacity of the wind power we have considered in our studies. And renewable electricity generation, I think this is the power plants installed capacity that is mainly used for generating electricity from the different renewable energies resources. And per capita in watts we have mainly included in our study. And here is the copper price per pound in US dollar, and nickel prices. And in this study, we also utilize the average mineral prices for our disaggregated model. So the average values of the nickel and copper we have included, we have considered in our studies. And this that the data is taken from the macrotrends data set, data portal. We have taken this copper and nickel price data, and oil price data is also taken from that particular sources. So this is the crude oil price in current US dollar we have considered. An exchange rate, a real effective exchange rate index, and sourced from the World Development Indicators published by World Bank, and income growth data and domestic product per capita GDP, and its base year is of course 2015, because this is the latest base year that are fixed by World Development Indicators. So this is our data and sources that we have used in our research. Model materials and methods. So we don't I don't explain it more, but some overview and overviews that I like to give here. First of all, for the panel data set, it very well, it is very mandatory. There is the issue of cross-sectional dependence. So cross-sectional check the issue of the cross-sectional dependence, we utilize the CD test, cross-sectional dependence test, coined by Pesser in 2004, and it will help whether the issue of cross-sectional dependence can hamper the co-integration and regression process. So it can help us to know whether the cross-section dependence exists or not. And the slope homogeneity test, usually most of the researchers use the Pesser and Yamagata test 2008, but very recently, not very recently, but in 2013, Blomqvist and Westerland developed, in the first slope homogeneity test developed by Pesser and Yamagata 2008, they considered the slope homogeneity, and there, and it was developed by Blomqvist and Westerland, and they used not only the homogeneity issue or heteroscedasticity issue, and they also added the serial correlation issue just to check the slope homogeneity of among the panel units or the particular variables. And we also utilized the panel unit root test, cross-sectional augmented decay flow CADF regression technique. So CIPS, cross-sectional IM and Pesharan test, as our data is mainly unbalanced. So we use the CADF panel unit root test. And after testing these three pre-estimation, using this three pre-estimation technique, we use the cross-sectional autoregressive distributive lag model, and it is coined by Chudik and Pesharan in 2015. So this technique is mainly, it has some advantages over the other traditional co-integration technique, because this technique consider one lag of the regressed variables and consider it as the weakly exogenous regressors within the framework of error correction mechanism. So that is usually not prevailed in the previous co-integration technique, and it also controls the unobserved issues. That is mainly seen when to measure the long-term effects in a particular co-integration and regression model, and it also tackle the cross-sectional dependence issue in the long run and short run. And this model is also appropriate while the data set is stationary at level and fast difference form. That means mixed order of integration it considers. And not only this, in the large data set, so I have not mentioned here, so but I have remembered this. So in terms of long data set, I think this model is highly fitted. So from that point of view, we have considered the cross-sectional autoregressive distributed lag model, and it also considers some of the heterogeneity issues, because OECD countries data are mainly consists of some different types of heterogeneity, heterogeneous panels we can consider. So from that point of view, using the cross-sectional autoregressive distributed lag or CSERDL model is appropriate for our study or for our data set mainly. So here is the empirical findings. So I think the slide is a little bit problematic to see, but as due to time constraint, so I have made it in this. I'm extremely sorry for this. So at a glance, firstly, the descriptive statistics result, we see that mainly we have considered here the within and between values. Within means the standard deviation within the panel units, and between is the within our variable specific standard deviation. So here we see that if we see the within and between issue, where we see that in all cases of our variables, we see that there is no significant deviation. So standard deviation is peripheral or marginal in case of our all variables. So we can consider that our data is normal in character, and the data feature is normal. It is not non-normal at all. So in that case, CSERDL technique can be applicable for this data set. And we also utilize this homogeneity, slope homogeneity test. Here, first one is Pesaran and 2008, Pesaran and Yamagata he produced, and this one is adjusted. It controls the heteroscedasticity and adjusted heteroscedasticity. So here the p-values are usually that is the less than 1% label. It is significant. So it is applicable for our aggregated model and also disaggregated model like copper imports, and it is called the nickel imports. So here we see the slope homogeneity, null hypothesis of the slope homogeneity is rejected here in terms of its p-value that is less than 1%. So from that point of view, we can say that there is no slope homogeneity issues existing in this model. After checking the slope homogeneity issues, we check the cross-sectional dependencies, that is CD test and panel unit to test. So here we see that the CD are significant, CD p-value are significant. In that case, there is no issue of CD. And for the average mineral price, copper price, and nickel price, and oil price, these four are the global variables. So in that case, CD tests are not applicable. So so we have avoided this, but because for the global variables, it is mainly time series data, and global variables main characteristics is that it is similar for all countries, because that is the global value or global price of the different communities. So CD is not applicable. Cross-sectional dependency is not applicable. In that case, we have even panel unit root test are not applicable here. So we utilize the time series relevant unit root test, where we see that but here CADF test we utilized, but in case of these four variables, we use the time series like ADF augmented decay fuller unit root test, where we see that our variables orders our variables are integrated in first order form. So overall, the presence of the CD and our variables stationary status, that means it is in the it is in the first difference form. So this particular findings direct us to utilize the cross-sectional autoregressive distributed lag CSERDL model. So here is our empirical findings. So firstly, here our dependent variable is mineral imports demand aggregated model. So installed wind capacity, it is the installed solar capacity model, and it is the electricity generated from renewable energy model. For these three models, error correction as usual negative. Here is also negative and significant. So we can see that there is the long term, it will be converged, just adjusting the short run disturbance from the long run equilibrium. It will of course reach, but it will take more time because the error correction ECT value is not larger, but it is a little bit lower. So here is our long run result. We see that installed solar capacity is positively significant. So the respond of aggregate mineral import positively respond to the installed wind capacity. That is also true for the installed solar capacity. But in terms of electricity generation, the aggregated minerals responses are negative. So this is the issue. It needs to have some explanation. Why? Because minerals are mainly used in installed wind and solar capacity, but renewable energy, electricity is also generated from the other renewable sources like biomass, hydrocarbon, and other sources. So it can be happened there. They imported mineral resources for utilizing the biomass or hydrocarbon electricity technologies, but it is not properly utilized. The different governments of the country, they spend the some minerals commodity for these like hydrocarbon and biomass biomass electricity general process, but it is not used properly. So and what was expected, that if it is not properly used, in that case we can see the negative consequences. So in that case, the aggregate minerals have the negative response, negatively respond to the electricity generated from the renewable energy. So this is our viewpoint, and we explain it in our papers. Here the average mineral price, it is negative. In that case, substitution effect, complementary effect, both are not applicable here. Oh no, it doesn't suit the Marshallian demand hypothesis, because it's there will be the uh, yeah, it is consistent with the Marshallian demand hypothesis, because demand and price will have the inverse relationship here. In that case, it is not appropriate. In that case, it violates the Marshallian demand hypothesis. So it is negatively related. In that case, we cannot consider that oil price is a substitute for the minerals. It is also applicable. There is also, but it is insignificant. In that case, it may be substitute for the minerals oil in that case. And this is the positive consequences of responses of critical minerals are positive to exchange rate here in our model. And GDP is here insignificant, but here it is positive in our installed solar capacity model. But in renewable electricity generated model, it is not, it is insignificant. Our short-term result is somewhat different, but so we have explained in our study. So I don't like to explain more. So here we also see the result here, the in terms of installed wind capacity. So our we find a positive response of copper imports. Here copper imports is the dependent variables. It responses is positive to the installed wind capacity. Here it is also positive, and copper's EU responses are of course positive in the renewable electricity generation here. So here are the some of the explanation. I want to avoid this. And finally, our response of the nickel imports. So nickel model, nickel is our main dependent variable here, where we see that the positive response to installed solar capacity here, and it is also positive. Its nickel's responses are positive in the installed solar capacity. But in case of renewable electricity generation, it is insignificant. Here, in terms of nickel price, it contradicts with the Marshallian demand hypothesis, because here is the positive relation, and here is a negative. Here is also positive in terms of nickel price. Here is also positive, and in terms of oil price, it is negative. So whether it is complementary or substitution effect, it is difficult to examine. So exchange rate is mainly positive in all this country, because most of the OECD countries, they have the strong exchange rate. So from that point of view, I think it may be the response of critical minerals import demand is positive to the exchange rate in the context of the OECD countries, while we measure the response of the nickel to the energy transition process. And GDP is of course positive, but here in terms of solar capacity, it is negative, and it is also positive in terms of renewable electricity generation. So this is our findings. So if we see at a glance, if we want to see these findings, so we can see that overall renewable energy production, especially solar and wind, foster the import demand of the aggregate minerals and disaggregate mineral demands also, like copper and nickel in the long run. And copper price elasticity demand sustains, while the nickel price violates the Marshallian demand hypothesis in the long run. And income has a mixed effect on explain the mineral import demand function. And oil price relevant substitution effect or complementary effects propositions are not proved in all models of interest, because we see the different heterogeneous responses of the critical minerals to the oil price. So in that case, in some cases, it is substitution effect is relevant. In other cases, complementary effect is effective. But in some cases, if it is negative relation, so these two propositions are not proved in our model of interest. So this is our overall findings. Finally, conclusion and policy recommendation. So conclusion and policy recommendation, it is somewhat I think larger here, I mentioned here, but some of the important policy recommendation are a must for these OECD countries, just to continue their mineral import, and this import driven cleaner energy production process. So first of all, this country, based on our results, this country should have the appropriate mineral trade policy. So you know it very well, the most of the minerals are mainly in some developing countries. The reserves are mainly in the different developing countries, and these countries are conflicting prone. I think geopolitical risk, that is the fundamental issues, and in some countries faces the terrorist attack and military government and other types of different overt and covert forces, fanatic activities that grabs that countries, mainly that countries who belongs to the huge reserves of the mineral resources. So from that point of view, these countries should have the concrete and pragmatic mineral trade policy. This, in that case, some import restriction or export restriction that should be withdrawn from their policy, from the mineral trade policy. If the country can take the appropriate mineral trade policy, then it will help increase the mineral volumes, as well as it will ripens the renewable energy production of this country. And appropriate mineral import policy is very important. Not only the trade means export and import. In that case, import policy or energy policy, because mainly it emphasizes the clean energy transition, energy or renewable energy policy that must be very pragmatic in terms of the contemporary worldwide scenario or situation. In that case, their policy, of course, must be import friendly, and they can persuade the external investors or the local investors to fund in governments different types of renewable energy project. This fund accumulation is very helpful to operate the expensive renewable technologies. and renewable technology is somewhat expensive than that of the non-renewable energy technologies. So in that case, different external investors like Japan and other countries, they have some technicians. They are well ardent about the renewable energy technology, and other countries experts, not only the expert, the investor that could be invited to operate this expensive renewable energy technology and their different plants, so that mineral exploitation for the clean energy production could be ensured in a particular country. And we see that mineral price, oil price, and exchange rates some heterogeneous effects in the case of our model. So in that case, OECD countries should rationally respond to these changes of the oil price, mineral price, and exchange rates. Here we see that is mainly caused by different types of exogenous shock, and that comes from the external policy volatility like war, economic recession, etc. If we see the current Russia-Ukraine war scenario, and that is drastic for the different types of imports or export, even international trade, Western countries and European countries, they have given a significant embargo on the Russian Federation, and Russia is the country resource rich countries in the world. It has huge mineral resources, copper, nickel, rare earth elements. So this country have. So only the one material commodity like the uranium. On the uranium, there is no embargo because 14% of uranium that is imported by the United States of America. Only this commodity, uranium, commodities or metals that are beyond the recent, the ongoing, sanction given by the United States and other Western and European forces. So in that case, in that cases, OECD countries should have the rational response to the geopolitical risks and other issues. So very recently, I produced one paper how the geopolitical risk affects the Russian uranium-driven USS nuclear energy consumption. So this paper, and 2 days ago, it is now under review in the resources policy. So why I have chosen this topic? Because only the uranium commodity or metal that is beyond the ongoing restriction imposed by the Western European nations. So it is very significant. So I produced a paper, and that is now under review in the resources policy. This is one of the Q1 journal, and it's impact factor more than 8. So overall, and another important issue that we see that the income growth has a mixed effect on. That means critical minerals response are not positive or negative. It is mixed. Not only it is mixed. So in that case, these countries should utilize their income potential for importing minerals. In this case, these income-driven structure of the renewable energy sectors of these OECD countries can help sustain the mineral import flow. So this is our suggestions. And finally, we know that global sustainability paradigms encompasses the renewable energy technology proliferation and production. So in that case, renewable energy productivity goal urges these OECD countries policymakers to utilize mineral resources or to import mineral resources for producing ample amount of renewable energy production. In that case, so if these countries policymaker and these policies become supportive for the mineral imports or import demand, then it can also help in the global vision for achieving a decarbonized or net zero emission trajectory by the 21st century. So OECD is the greater bloc all over the country, 29 countries. So this country's renewable energy production has the huge contribution to the energy transition process worldwide. So in that case, their renewable energy production using the critical minerals that will, of course, help reach the net zero emission trajectory by the middle of the 21st century, and that is propounded by the recently held global summit COP26. So that's all about my presentation. Thank you very much for your cooperation and patient sharing. So if you have questions and suggestions, you can tell me. I'm ready to hear your comments, suggestions. Thank you very much.
Thank you, Bhai, for your wonderful presentation. The floor is open for the audience to present any question. To conduct a really clean question and answer session, I'd like to ask the audience to raise their hand if they have any query. Then I'll go accordingly, one by one. Wait for a few minutes for the raise of hands.
I think by 1 hour I have finished.
Yes, successfully.
Thank you.
I see one raise of hand. I'd like to request Mr. Nafis Farabi to present his question.
Thank you, Mahdi Bhai, for giving me the floor. I would like to thank the speaker, Monirul Islam sir, for his wonderful presentation. I have really enjoyed the presentation throughout the last 1 hour. So I have two suggestions or two concerns that I want to ask the presenter. That the first one, that you talked about the mineral rent and you showed some figures on mineral rent, but I think it's somewhat a tactical word in the renewable energy field. But I just wanted to know that what does this mean? What is the meaning of the mineral rent? So could you please explain a bit about it? And also, in the later part of your presentation, you said that you found a heterogeneous effect of the income factor on the mineral import demand. So if you could please explain a bit about this also, because I'm a bit confused that what is the meaning or what is the explanation of this statement. So thank you.
Can I answer now?
Mr. Farabi. I'd like to request Monirul Islam Bhai to take note of the question and to answer all of them after the question and answer session.
Okay, thank you.
Following the first question, I see another raise of hand. Our director, Sir Dr. Mahmoud Tariq, could you please present your question?
My heartfelt thanks to Monirul for producing such a beautiful papers. And I am really glad to see Farooq is here, Tahamina is here, and Mazhar is here. So, my thanks also go to them. Actually, just simple sort of queries. First query is copper, nickel. Are these two not minerals? Then why you have developed three models, with one with minerals and other one with copper and one with nickel? My second question is, it seems that very, subtly you haven't mentioned who are the exporter of these minerals, copper and nickel. You basically look into the OECD countries and you look into the prices of this and their relationship with clean energy. But I think regarding the policy issues and sustainability of clean energy, production of clean energy, the issue also where are those minerals and how they are used and what are the stock at present time and whether there is any geopolitics involved there. With these few queries, I'd like to end here. Thank you.
Thank you,
Thank you,
sir,
sir.
for presenting your question. And these are all the two questions that has been presented by our audience. I'd like to go on to Mazhar Bhai for answering the question.
Mahadi bhai, I think Sultan sir raised his hand.
Unfortunately, I didn't see that. I'd like to request
Mahdi,
Sultan Ahmed.
I'm not Mazhar, I'm Monirul.
Sir, I'm extremely sorry.
No, it's fine.
I'd like to request Dr.
There are two
Sultan.
hands. There are two hands.
I see. I'd like to request Dr. Sultan Ahmed sir to present his question.
Thank you, Mahdi, for the opportunity. I thank very much Monirul for your very extraordinary, excellent paper presentation and the findings. I follow your postings and I am very much delighted that you are striving for your excellence. So very sincere thanks from me. And my question is, as you have identified a very crucial impediment to production of renewable energy technology or products, very rightly pointed out, and you also mentioned mostly the OECD countries, they should come up with policy, I would say, policy intervention so that the global commitment for renewable energy production, maybe some countries declared a net zero carbon by 2030, some on 2040, 2050 sort of thing. So there will be a great challenge of renewable technology development if nickel, copper, this kind of very essential minerals are not in movement. This is a good finding. One point is that these extraordinary findings, how the recipient audience, I mean the OECD countries, will take into consideration how you are thinking from your point, from your location to make OECD countries aware of this. They're aware, but this is a research finding. This is one point. And another point is for a country like Bangladesh, a developing country. We have power system master plan, and we have identified that we should have our renewable energy at least 10% by some maybe 2035 or 2040 sort of thing. And we are in a position to invite renewable energy technology from other countries like China and other countries. And now the renewable energy productivity increased by 4 times of the previous technology. So that is one positive thing. But again, a country like Bangladesh, how the country like Bangladesh will face problem in achieving the target of renewable energy in the country. If you can have some specific suggestion for a country like Bangladesh, that would help greatly, as that will be the implementation of your suggestion. So thank you so much.
Thank you, sir.
Thank you, sir, for your question. I'd like to move on to Mohammed Mazal Bhai to present his question.
Thank you very much. First, I would like to thank the ReForm platform and our honorable director, sir, to have such a good initiative to share the knowledge and also share the research output that will enrich our knowledge and potential in research. And also, I'd like to thank Monirul sir to present the paper. It was an awesome paper, and I think like Monirul sir is a kind of inspiration to all of us because he is from the political science background, but he's doing a good research and also produce some good papers in a quite tough field in econometrics and energy field. So that was very much inspiring for all of us, I think. So my question is actually, I'm not asking a question because this paper is published, and I'd like to suggest some potential and some future aspect of this kind of research, like in my country, like Bangladesh, where we need a good renewable research, renewable energy research, and also we have some lackage in energy resource and also others. So how we can take this kind of research more further to produce some impactful or insightful research in renewable energy in Bangladesh, because I see in a lot of places the renewable energy is growing, and people like in modern world, they are moving to renewable energies. They are using electric cars and also the solar panel and the wind energy they are using. But how we can so it would be great if you provide any research, or if you take initiative to do any research which will move our energy sector in my country, like the Bangladesh energy sector, more forward with the renewable energy resources like solar panel or other sources. So that would be very great for my country, actually. Thank you very much.
Thank you, Mazal Bhai, for your question. I see no more raise of hand. With this, I'd like to move on to Monirul Islam Bhai to answer all the presented questions.
Thank you very much. Can you hear me?
Loud and clear.
Yeah. The first question, Nafis Shahriar Farabi. So this is, of course, a critical question. So the graph I showed here, it is not the mineral range. It is not the mineral range graphs. This is the import volumes. The OECD countries mainly imports from the other countries in the world. And why I mentioned, because I also mentioned here the mineral range, because using the mineral, I think there needs to have some payment. So if the payment of a particular country that is higher, so that will also increase the capacity or potential to even import from the different sources or different countries. So in that case, I mainly use the mineral range from 1919 to 2017. So I have given a graph, but the graphs that I showed here, the graphs mainly shows the mineral import volumes that these countries, imported from external countries. So this is the first question. And heterogeneous effect means somewhat positive, somewhat negative. We see here in GDP. In all cases, it is not positive, but the assumption should be like this. It, of course, would be positive. But in some, here is the negatively insignificant, here is the positive, but here is insignificant. So here is also negative. So in that case, it is a mixed effect. I think not only positive, but it is negative also. In some cases, it is insignificant. So from that point of view, I think I suggested that these countries should properly utilize the potential of their income growth just for importing critical minerals, for stimulating their cleaner energy production process or system. So I think it is clear to Mr. Nafis Al-Farabi. Then our honorable directors are, rightly pointed out some issues. Of course, sir, copper and nickel also are the, metallic minerals. So first of all, in our first model, we utilize the aggregate mineral imports. It not only covers the nickel and coppers, but other minerals are, considered when we consider this is the aggregate minerals. That means cumulative minerals. That means it covers each and every dimensions of the minerals. So firstly, it is our dependent variable here. This is our dependent variable aggregate minerals. And now we have disaggregated the total minerals into copper and another one, nickel. So then I also look into what are the responses of the copper and nickels to the clean energy or energy transition process. So of course, these two dimensions are also minerals. Firstly, we use the aggregated measures of the minerals, including all the minerals resources, and then we can take the cluster format of the minerals like copper and nickel, how they respond to the cleaner energy transition parameters. So this is the question. And exporter of the minerals, sir, for your kind information, we mainly consider the import volumes. So we didn't utilize here the exporter countries, but I have conducted another study using the gravity model where how the Indonesian minerals commodity help augment the renewable energy generation for the other 18 countries. That paper is also under review, and we got revision and we submitted revision also. So here only the imports we considered. It was I could mention the sum of the exporter from which country they imported. That would be that could be good for the audiences just to understand the issue. Thank you, sir, for your nice observation and question. And geopolitical risk, this yes, sir, it is the one of the, I think, limitation of this study. But in my another 3 or 4 studies, I considered geopolitical risk, and one of the paper is very recently published. I considered, so if I show you, sorry. So this is the one article that is published in Resources Policy, where I use the geopolitical risk issue. And geopolitical risk and mineral-driven renewable energy generation in China. So we had a decomposed analysis where I tried to analyze many things, how the different decomposed measures of the geopolitical risk, like geopolitical risk acts, geopolitical risk threats, how geopolitical risks respond to the renewable energy generation in China. And I have produced another paper that is also published here, how the impact of the economic policy uncertainty. So this is the one of the Q1 journal, Mathematics. Here it is also published. Do geopolitical tension and economic policy uncertainty reorient mineral imports in the USA? Effective data analysis using the novel quantile approaches. So that was the limitation, and further we studied it, and we considered, even in my thesis, I have also incorporated the geopolitical risk issue, how the geopolitical risk impact the mineral imports or export, and this import and export driven energy, global energy transition. Thank you, sir, for your keen observation, and it is really laudable. Thank you, sir. And Sultan sir, his remark is of course fine. His mainly his question is like is how OECD will take your research findings. So I don't know how they will take my research findings, but this article is published in one of the A-star journal. There is the Energy Economics. Hopefully, it is based on the OECD countries, OECD and its policymakers, and different other authors can cite, and the concerned authority can take this paper under their consideration, and they can look into it and they can utilize maybe, but I don't know whether they can get this paper or not. But thank you for your observation. And another point he raised, how our country Bangladesh can take the opportunity. We have the huge mineral resources. So yes, and how can the mineral could be used for increasing the energy transition, renewable energy generation in our country. So renewable energy based, there are some other studies, and they have the some crucial suggestions here. Our minerals mining and extraction, that will be the I think fundamental problems, because mineral extraction and minings, that is critical. In that case, we need to hire the experts from other countries, and somewhat mineral extracting is not environment friendly. So there will be some problems, but policymakers should have some pragmatic policy measures so that they can be committed to extract our mineral resources. But how much mineral resources we have, I think still I don't know, but we need to explore this. And in terms of renewable energy production, or like solar home system, that is also this paradigm is also practicing in our country Bangladesh, and people are being benefited. But renewable energy is somewhat expensive, and Masukuz is one of the researcher. He did a study mainly on the consumers' perception about the renewable energy consumptions. So here he got the good results. People like to use the renewable energy, but there are some problems like the issue of the governance, and there is some issue of the materials and they are using. In that case, they have some negative findings also. So in that case, these countries, mainly our country Bangladesh, overall our country Bangladesh has a huge opportunity. This country can utilize its mineral resources, but there must have the significant policies from the governments. Our country is developing day by day, and still this country faces COVID-19 and other types of problem, but still the country is going well, forwarding well. So we, of course, for the next, I think we have to extract our mineral resources so that we can use for stimulating our renewable energy production process. Thank you, sir. So this is my, I think, viewpoint. I don't know how it will be applicable or not, and when it will be applicable, I think, I don't know. But we have the huge potential. Our country, Bangladesh, has the huge potential, and we can exploit this potential for satisfying the global vision of energy transition or clean energy transitions. And finally, Mazhar, has a good question. Not question, his observation is fine in the context of BD. So I already, answered, and Mazhar's observation is really fine. I am also thankful to our Dr. Mohammad Tariq sir for his initiative to organize such types of webinar, seminar, like symposium. So it is of course inspiring, and we are all gathering knowledge, but due to time constraints, sometimes we can participate here. But with the people are living outside the country, we must have to join. And I will try my level best to join in every session, but 1 or 2 sessions I joined, but not for all times. But I joined. So I saw some good presentation there. Thank you, sir. Thank you, all of the participants and who questioned, who suggested, and who has listened to my talks. Thank you very much.
Mahdi,
Yes, sir.
before I just want to, it is outside the presentation intervention. Usually, a PhD students needs to publish maximum 3 papers to get a PhD. It seems, Monirul, you have already published around 10 papers. So when you are going to get your PhD? This is my first sort of outside in a presentation. And today is a very special day that all our colleagues who are now doing their PhD in some universities, they have joined Farooq, Mazhar, Tamina. So I will be very happy if I see some of you to present next, because we belong to the same sort of team, same spirit, and I will be very happy if I see that you are coming forward. Even Tamina, you can be ready.